Hi everyone! Welcome to this PCB design course. Here, you'll learn how to turn your circuit ideas into real professional PCBs used in everyday electronics. We'll start from the basics. What a PCB is, explore components, and use design software to build your own boards. Let's begin your journey into PCB design.
PCB stands for Printed Circuit Board. PCB is the heart of almost every electronic devices that we use, from your phone to your robot. It's what hold all the components in place and connect them with the help of the copper tracks, replacing all our messy wires. There are four main parts of a PCB. First one is the substrate, which provide the structure for the PCB. Second is the copper layer, which conducts the electricity between the components. Third is the solder marks, which is the green coating that insulates and protects the copper. Fourth is the silkscreen, which shows the component layer and its polarity. So why we use PCB? Because it's compact and organized design, easy for mass production, it reduces the wiring, better electrical performance. But when you design a printed circuit board, we have to use a specialized software which is called as PCB design tool. For beginners and hobbyists, tools like KiCad or EasyEDA are perfect. They are free and they have a strong community, and you can also get schematic to port without breaking the bank. If you are working in industry or designing multi-layer high-speed board, professional tools like Altium Designer or Cadence are usually used because they provide advanced routing, simulation, signal integrity, and collaboration features. In this course, we will use KiCad because it's accessible, powerful enough for our project. Let's begin with downloading the KiCad software. For that, open a browser and in Google, search for kicad.org. This will open the official KiCad website. Now in KiCad, we have a very good documentation. Here you will find everything you need from user guide and tutorials to developer resource and reference manual. The Getting Started guide is perfect for beginners, so make sure to explore the documentation section. Let's go back. In order to download the KiCad, you can click on this download button. Once you click on this download button, it will ask for the operating system. Since I am using the Windows, I will click on this Windows. If you are using a different operating system, you can select the operating system from here. I will click on this Windows. After that, according to our region, or download the KiCad software. You need to click on this. If you go to your download on the top right, you can see the KiCad 9.0.exe file is getting downloaded. Once it is downloaded, you can click on this .exe file. Now it will start the installation. A pop-up window for the setup will open up. You need to click on this next. Again, you need to click on this next. It will say you need a minimum of 5.7 GB of space required for this installation. Click on this next and select the destination folder for the KiCad. I will click on this install. Now it will start the installation process. Once it is installed, you need to click on this finish and it will launch the KiCad. Now this is the KiCad project manager. So it has different options. So the first one is the schematic editor. Then we have symbol editor, PCB, footprint, Gerber viewer, image converter, then calculator tools, drawing sheet, editor and plugin, and content manager. So this is the central hub which has the schematic and PCB layout, managing libraries and project files on the left hand side. So in order to create a new project, from the top toolbar, you need to click on this file and then click on new project. Once it is downloaded, you can click on this .exe file. Now it will start the installation. A pop-up window for the setup will open up. You need to click on this next, next. Again, you need to click on this next. It will say you need a minimum of 5.7 GB of space required for this installation. Click on this next and select the destination folder for the KiCad. I will click on this install. Now it will start the installation process. Once it is installed, you need to click on this finish and it will launch the KiCad version. Now this is the KiCad project manager. So it has different options. So the first one is the schematic editor. Then we have symbol editor, PCB, footprint, Gerber viewer, image converter, then calculator tools, drawing sheet, editor and plugin, and content manager. So this is the central hub. So in order to create a new project, from the top toolbar, you need to click on this file and then click on new project. Navigate to the directory where you want to save this project and give the file name as breadboard PCB. .kicad underscore pro will be the project file name or the file extension. After that, click on this save button. So in the project file, we have this breadboard PCB KiCad underscore pro, in which we have the KiCad PCB and the KiCad schematic file. We will now click on this first icon, which is the schematic editor, and let's start building our circuit. We will design the schematic for the breadboard power supply. So we have the input as 9 volt, which is the power, and we will use some regulators like 5 volt regulator and 3.3 volt regulator with some component like capacitors and resistor. And finally, we will uh, place an header pins which will be connected onto the breadboard. So this will provide 5 volt and 3.3 volt on the breadboard. So let's get back to the schematic editor. So this is the schematic page. You can zoom in and zoom out with the help of scroll from your mouse. Alternatively, you can use the plus icon and the minus icon to zoom in and zoom out. Let us now explore this sheet, and we will first go to this page setting from the file and then click on page settings. You can select the sheet size, which is A4, A3, A2 according to our circuit. So if the circuit is big, so you can select the page accordingly. You can even change the orientation to landscape. Assign this date from here. I will write 1 as the revision and the title will be breadboard power supply. You can even add your company name and you can add some extra comments. Once you have added the details, you can click on this OK button. Let us start by adding our component. On the right side, you can see a symbol like op-amp, which says place symbol. You have to click on that. This will load the symbol and the footprint libraries. Choose symbol dialog box will appear, and in that you can search for the required component. The first component I require is the DC barrel jack. So I will search for barrel jack. I will select this, and the second thing I will like to is discuss with you is the assigning the footprint from this. Come to this drop down which says no default footprint. If you click on it, you can select the footprint whichever you require. I will select this barrel jack horizontal. I will click on that, and then I will click on OK. So this will assign the footprint to this symbol. I will click on OK. So now this symbol barrel jack will be tied to your cursor, and you can place the symbol anywhere on the screen on the sheet by left clicking from your mouse, and then press escape. The second component which we require is a fuse. Go to the place component icon and search for fuse. Click on the fuse, and I will use the SMD fuse. But before that, let me explain the two types of component. One is the through hole component, and the other is the surface mount component. Through hole component, also called THT, have long leads that passes through the holes in the PCB. They are perfect for beginners because they are easy to solder and ideal for project that needs mechanical strength such as Arduino board or power circuit. Surface mount device, which we call SMD, are much smaller and are soldered directly onto the surface. These components are placed on one side of the board and are commonly used in compact electronics like smartphone, wearables, and IoT devices. They make automated manufacturing faster and allow more components to be placed on a smaller board. So let's come back to the schematic, and I will select this 0805 size fuse. You can also see 0402, 0603 and other size. So 0402 is much smaller than 0603. This is the footprint for the fuse of 0805 size. After that, click on this. Now we will click on OK once you are confirmed with the footprint. Zoom in, and to rotate this fuse, you need to click on R key from the keyboard. I will place this fuse next to the barrel jack. The input to this barrel jack is 9 volt and it will come on the PCB. But when it will be powered, I want an LED to glow. So let's place an LED with a current limiting resistor. Click on place component and search for R in resistor and select the footprint of 0805 size. And then click OK. After this, place it to the parallel to the fuse, and after that, add an LED of size 0805. Place this LED in series to this resistor. We have added the barrel jack, fuse, resistor and LED. All of these components have a designator and a value. For the resistor R1, we have to change the value. For that, click on the resistor, right click on it and go to properties. Change this R to 1 kilo ohm and then click on OK. Now in the schematic we have R1 as 1 kilo ohm. Similarly, we have to change the value to the LED if you want. After that, I will add two capacitors. One is the polarized capacitor. For that, go to the place component and just search for C. Then select the footprint of 5 cross 5.8 millimeter size and then click on OK. After that, I will add one more capacitor in parallel to this capacitor. I will add the package as 0805 size. I will like to move this text. I will left click and then click M key. After that, I will change the value of this capacitor. Again, go to properties and I will change this to 100 microfarad. Similarly to the other capacitor. This is 0.1 microfarad capacitor. After that, I will add AMS 1117 5 volt. So this is the package SOT223. Click on OK. So on the left side also you can see we have the details for this IC and along with their data sheet. So if you want, you can refer from this. I will click on OK. I will place it in this place. Now after this, I will use this draw line or draw wire tool from the right hand toolbar and start connecting the symbols. Left click on this circle which you see on pin 1 and again left click on the circle for the fuse to complete the connection. Similarly, do it for all other symbols. Add a ground symbol from the place component. For that, just search for ground and you can select this ground. Click on it and click OK. I will place this ground in this circuit. After that, we want a two capacitor of same value. So in that case, I will copy this by selecting and then Control C and Control V to paste it. Similarly for the other capacitor. Also, I will add the AMS 1117 3.3 volt IC. And again, I will copy this to capacitor at the output of the IC. After that, I will connect all of the connections. We will add an LED at 5 volt and 3.3 volt. For that, we can copy this resistor and the LED, and I will paste it here. We'll change the value of this resistor to 560 ohms, and on 3.3 volt, I will have 330 ohms as the resistor value. Let us complete the rest of the connection. Now I will add the net label. So from the right side, you can click on this place net label and you can label it. You can even change the font and size of the net. Give the label name as 5 volt and then click OK. And I will place this 5 volt net on this output of this regulator. Similarly, I will add the 3.3 volt net. Now we will add the 3-pin header, which help in selecting the 5 volt and 3.3 volt with the help of jumper. So for that, go to place component and search for CONN 1 cross 3 because it is 1 row 3 column, and you can even select the footprint. In that case, I will select the header pin 2.54 mm and it should be vertical. The pitch size is the 2.54 mm. So this is the connector. So at pin 1 we will have 5 volt, pin 2 we will have V out. So when we want 5 volt, we will connect 1 and 2, jumper on 1 and 2. If we want 3.3 volt, we will connect it to 2 and 3 because 3 will have 3.3 volt connections. So I'll place it here and then I will connect it to 5 volt. After that, I will place a net label for V out, which is on pin 2, and pin 1 is 3.3 volt. So in that case, I just copy and paste this 3.3 volt net on pin 1. After completing this, I will require a connector of 2 cross 2 connection so that we can connect this to our breadboard. So for that, go to place component and again search for the connector. So in connector, come to this generic connector and you will find 2 cross 2 odd even connector, and you can select the footprint accordingly, which is the pin header. 2.54 mm is the pitch. Similarly, we will need one more connector. I will place this connector at the bottom to arrange my schematic. Connect the pin 1 to pin 2. So this will be connected to each other for both of the connector, and we will connect it to ground, which is the minus. For pin 3 and 4, connect it to each other. And then we will connect the V out to this pin 3 and 4. Come to this top toolbar and click on place, and then come to this draw rectangles. Start from here and select this part. Click on escape. Again, do the same thing. Place, draw rectangle. I would like to place this in this way. Okay. Now we are trying to arrange the schematic. This is a circuit which consists of 5 volt and 3.3 volt. From the right toolbar, I will select the text, power circuit 5 volt and 3.3 volt, and click on enter. So this will help us arrange the schematic in a proper way. Header for connection to board. Click on OK. So I place this and this. So let's say we have two of the component of same value. Let's say 100 microfarad and 100 microfarad, but this should have a different designation. So annotation help us do that in an easy way. So if you click on this annotate, whichever component is not assigned, this will automatically assign a designator to it. So you just need to click on this annotate and it will say annotation complete. If there is any error, it will show in this error. Now you can close this. After that, the second thing is the electrical rule check from the top toolbar. Click on it and it will show the errors in this window. But for that, you need to click on this run ERC. ERC stands for electrical rule check. Now you can see there are two violations and four of the ignored tests. So ignored tests are fine, but in the case of violation, you have to be extra careful. So it say error, input power pin not driven by any output power pins. So if you click on it, it will show an arrow in this schematic on the red color. So it is showing an arrow on the ground and second on this input pin of AMS 11175 5 volt. So it says that this pin is not driven by any power source, even the ground. So what we have to do is you have to close this, come to this component symbol, and you need to place PWR flag on this So now we have placed this our flag. Again, you can click on this ERC, click on run ERC. Now it is not having any errors. Click on this close. Come to this zoom to object from the tall toolbar and it will zoom to the particular circuit. After that, assign footprint button to assign the symbol footprints. So this will assign all of the to that symbols which we have used in the schematic. So I think we did this earlier, but if any of the footprint is not assigned, you can assign it from this button. So if you can see this connector J4, it not assigned any pin headers, this one. So what you can do is you can come to this footprint assignment and come to the connectors, and in the bottom left come to this pin header, come to 2x2 pin header. So 163 connector pin header, 2.54 pin headers, 2x2, 2.54 mm vertical. So this is what we need. So now what you have to do is you have to double click on this particular footprint. You can also view this footprint by coming to this view selected footprint from the top toolbar, and also you can see the 3D view from this button. You can use your mouse to move it here and there. You can see these headers which we are using in 3D. I will close this footprint. Since I've assigned this, all of the components have been assigned a footprint. After that, I will click on this apply, save schematic and continue, which is very important. And then I will click on OK. Now you have successfully completed your schematic design. Once you have completed with the design, click on File, click on Save. Click on this Switch to PCB Editor from the top toolbar. In this also you will get the sheet, and on the bottom we will have the details for the sheet. Now the first thing and this we have to do is click on this Update PCB from Schematic button from the top toolbar. So what will happen here is once you click on this Update PCB button, all of your changes in the schematic will reflect in this PCB editor. So let's do that. Click on this Update PCB and it will not show any errors or warnings. Now you can close this and you can see this list of footprint is tied to your cursor. You can click anywhere in this sheet and then click on escape. You can zoom in and you can see all of your footprint is in this bunch. So you have your components. Now let's start with the design. Okay, let me walk you through the interface. So you have different shortcuts on the top toolbar and we can see it one by one. And the first thing I want to show is the track. This is the predefined track width, but you can edit it from this edit predefined sizes. So in this you can add your track width. Let's say if I want to add 0.5 mm width, and if I want to add a via of size 0.5 and hole size is like 0.3, so you can add this and click on OK. So if you do this and then again come to this window and you can see this 0.5 mm track width is visible in this window. Next is the via. Since I've selected or added a new via, you can also do it with this edit predefined sizes. You can select the different copper layer which you are working from there. Then important thing is this grid size. So grid size is this grid which you see in this spreadsheet. You can change this grid size like 5 mm, then it will place the grid at 5 mm distance. So I'll recommend to use 0.5 mm or 1 mm grid size. After that, we have different shortcut on the right side and the appearance tab on the right side, which lists the different layers that we are going to work on. Then we have the objects, then we have the nets, the different nets that we have in our project, which is 3.3 volt, 5 volt, V out, ground, and other nets. Let's come to this layer. So if you see, we have this arrow on this red color, which is f.cu, and you can see one eye. So if you click on this eye, the red color layer will disappear. If you click on this again, you can see this red. So this is actually the red color is actually the front copper. F stand for front, B stand for bottom. So this will help us when we are working with different layers. Let's say we are working with f.silkscreen with its front silkscreen, B is for bottom silkscreen. Now, first thing that we going to do is the working with the edge.cut layer to define our board size. So for that, come to this edge.cut from the appearance tab and zoom out. After that, click on this draw line from the right toolbar, which is the shortcut. Now let's start with defining our board. Left click in the PCB editor and it will show you the length of the line in millimeters and the angle of the line which you are trying to draw. After that, we have to draw a horizontal line of 30 millimeters. Once it is 30 millimeters and the theta angle is 0, left click from the mouse and change the direction. After that, I want a vertical line of 7 millimeters and horizontal line of 7 millimeters. Then the vertical line will be of 38 millimeters. So draw the edge of the board as per this dimension. The end, click on the starting point of the line. This completes our board dimension outline which we require. Once our board outline is ready, change the layer to f.cu, which is the front copper layer, from the right hand side of the window. Let's start with placing the component or the footprint. I will drag this PCB editor on the left side and the schematic editor on the right side. Now come to the input part of the schematic. Click on this DC barrel jack, and as soon as you click on it, you can see the footprint of the barrel jack is highlighted in the PCB editor. Come to the PCB editor and click on this barrel jack. Now to move it, click on M key from the keyboard. Now we have to place the connector onto our board. So place it at the edge of the board. We have to place the component as per the circuit. Let's come back to the schematic. Second component is the fuse. Click on it and move it onto a board. Now I will place this fuse next to the barrel jack. You will notice a white thin line between these two pads. This indicates there is a connection between these two pads. When we route the track, it should have a minimum distance between the two pads which are connected. After that, the next component is the resistor and the LED. We can rotate the component because you can see this white line is connected between these two pads. Place the LED in the same way. Similarly, rotate the component with the R key from the keyboard. Now place this capacitor in the similar way. So I will try to place it somewhere near to the connections. Similarly, do it for all of the component. I will place this capacitor. Make sure you do not overlap your component. There should be a distance between the two components. Let's place this AMS 11175 volt. After that, the capacitors. I will place this J2 connector somewhere in between these two IC. You can move this if you want. So these headers will be used by the user in order to select the voltages, 5 volt or 3.3 volt. I will place these two connectors which will go onto the breadboard. So you can see this component are on the top side. So the red color shows the front dot copper. Now, in order to place these two headers on the bottom side of the PCB, so I will show you how to do that. But before that, click on this view and 3D viewer. So if you see all of this component are on the front dot copper or on the top side of the PCB. Even the through hole component are on the top side. Now we want these two headers to be placed one on top and one on bottom, but on the bottom layer. So in order to do that, we can close this and come to this header pins and click on one of the headers and click F key from your keyboard. So this will move the component on the bottom side, similarly to the other connector. You can verify it by going to view and 3D view. Now you can see these headers are facing downward. So this is how you can switch the layer from front to bottom. Now let's move this header to this position. The second header on this position. Now I have measured the distance between the two pins. Distance between the two pins should be 47.5 millimeters. So in order to measure that, I will maximum this, and from the right hand toolbar, you can click on this draw orthogonal dimension at the bottom. You need to click on that. On the first header, center of the first header and the center of this bottom header. So this shows me 47.5 millimeters, which is exactly what I wanted. So I have calculated this distance from the breadboard. So I will delete this and let's switch to this 3D viewer, and this is how the placement of the headers will look like. I will try to rearrange some of my component on this board because I see some space and some of the component are in congested place. Let's move it one by one. Okay, so now let's move to routing of this board. So for that, we will start from the circuit or the schematic. We'll start with the input. So this was our first pad. Click on this route track from the right toolbar. This will, let's start with our first connection, which is the barrel jack connection. I will click on this first pad, pad number 1, left click on it, and you can see it highlight the other pad where we need to connect it. Make sure to not have a 90-degree angle. Just connect it directly to the second pad. Left click on the other pad to complete the connection. Connected the barrel jack with the fuse. The second terminal of fuse connect to the resistor. So let's do that. Click on the second pad of the fuse and then click on this resistor R1. Now click the other end of the resistor to the LED. Do not worry about this ground connection, we will do it later. Now the other end of resistor goes to the capacitor. So let's do that. Similarly, do it for all other pads. I will connect this to the pin 3 of the regulator. Sure you have a 45-degree angle when you are moving the trace. We'll connect this to 5 volt. to do the connection for these headers. So, so V out should be connected in this way, but we have to connect it in in this terminal on this pad, but it's quite long trace. So what you can also do is, since this header are on the bottom side also, so I will switch the layer to b.cu, and as soon as you switch it, you can see this headers are shown in blue color. So now you can click on this trace or the track width and make the connection on the bottom. Now click on that and click on this pad, which is a through hole, and you can change the direction by left clicking and left click on the pad where you need to connect it. Similarly, connect it on the bottom side. So you are done with the connection. On the bottom, you can see it lists the pads, number of pads via track segment that you have used, the nets, and the unrouted connection. So now it's showing me 16 unrouted connection. So I'm assuming it's the ground connection. So let's move further. Maximize this window and let's work on the copper pour. So we will do a ground copper pour. In order to do a copper pour, click on this drop field zone from the right hand toolbar and left click on the edge of the board. So as soon as you left click, a pop-up will open up which shows zone properties. Here you need to select the net. So in my case, it is the ground. You can also select the front or the bottom copper wherever you want the copper pour. So now I will click on OK. Now you can move your mouse and you can see this white thin trace will be tied to a cursor. You just left click on the edge of your board. Do not go out of your board and do it for the complete board outline. This board copper pour at the starting point and zoom out. You can see this thin trace at the edge, but you cannot see the copper pour. For that, go to edit and click on fill all zones. See, you can see a red copper pour on the board. So this has a connection with the ground. So this is a ground copper pour. Once you have done with the copper pour, you can come at the bottom and you can see it shows one unrouted connection. So it's possibly the connection between this ground with the ground pad. So we do not have a connection because of some issues. Now how to resolve this? The first is we can use a via, a ground via, which will connect the top copper with the bottom copper. So for placing the via, from the right side, click on this place via and click on this copper pour. Do not place on the pad. Click on this pour and do not even place on the track. I would like to place two vias in this way. But you can see this via is only connected with this red, which is the top copper or the front copper. View this in 3D view. So this is a copper pour which is in green and this is our via. So this via is not connected anywhere on the circuit. Let's put a copper pour on the bottom side also so that we get a connection with the front and the bottom copper. To place the copper pore, do the same thing. Click on this and then click on the bottom.cu and then click OK. So this will create a copper pore on bottom layer as well. So now you can see we have a blue color, which is the bottom layer. So this is the copper pore. So you have done with this, you can see 0 unrouted tracks. Now let's work on the Silkscreen layer. Come to this J1 and click on it. So you can see this is on the Silkscreen. So the yellow part or the text which you see, it comes on the Silkscreen. So what we can do is we can edit it from the, you can come to the schematic and you can change the J1 to a different text and then it will reflect it on the PCB editor. That in the schematic, you can click on edit and you can edit this reference. I have written it as PC power. So in order to reflect it on our PCB, so what you can do is you can first save this in the schematic and come to this PCB editor. And then click on this update PCB button. Click on annotate. It will show annotation complete without error and then click on update PCB. This will update the schematic, update the PCB with the schematic. So you can see we have the DC power written it on the, you can see the J1 is replaced with DC power. Similarly, you can do it for all of the component, but make sure you do it all at once in the schematic and then click on update PCB. We'll change this LED to PWR LED, which represent the power LED. Similarly to this LED, I can change it to 5-volt LED because this LED will glow up when we have 5-volt power. And for this LED, I will write 3.3 volt. Again, click on this update PCB and do the same steps. After that, you can arrange this text by moving it to onto the board. Do not make the Silkscreen out of the board. So I will arrange them one by one. Now we can even add extra text onto our board. So to do that, we can come to this uh, view and then click on footprint library browser. This will open the footprint library, and in that in the filter search for the symbol. I need a symbol library. So in symbol library, you can get different symbols. Let's say UKCA or CE, then EST logo. I'm specifically interested in this KiCad logo. So it says KiCad, designed with KiCad. So I will click this and I will place it somewhere on this part. Likewise, you can add other symbols onto your PCB. If you come to this 3D view, you can see this symbol is on a Silkscreen layer. Okay. So I need one more symbol. Let's say if I get this open source hardware symbol. Oh, this is quite big. I can change the size of this logo or the symbol. And I will select a smaller symbol and I will place it somewhere here. In order to, if I want this to be moved on to the different layer or the bottom.cu, I will just press F key from my keyboard. So it will switch to the bottom layer. Now I will add text from this right toolbar and I will select bottom.Silkscreen and I will write some text like breadboard power supply version 1. You can even change the size of this text and the font. I will click on OK. Then I will place it somewhere on my board, but I want this on the bottom side. Right now it is on the top. Okay, I did some mistake. The text is showing in mirror image. So what I can do is I can change this. I can change this by just going to the text and I will click on it and just press the F key. So now if you go to this 3D view and you can see that, yeah, now it's correct. So I get this breadboard power supply as the text and the open source hardware symbol. Okay, you can place it anywhere on your board. I would like to move it somewhere here. Now, now it's quite better. This was working with the Silkscreen. After this, we have to do the design rule check, which is the DRC. You remember we did the electrical rule check ERC in this schematic. Similarly, we have the design rule check in the PCB editor. To do that, click on this inspect and then click on design rule checker. Now in this, the dialog box will appear. You just need to click on this run DRC. So it will do some tests and it will not show any error or warning. So in my case, it is showing 0 errors. And there are some ignored tests, so that is fine. And then you need to click on close. So now you have successfully designed your own PCB board in KiCad. Now the next step will be to generate the Gerber file and send it to the PCB manufacturer for printing. In order to generate the Gerber file, go to File and click on the Fabrication Output and click on Gerber file. This will open a window which will list the included layer, and you just click on this plot. It will generate the Gerber file uh, on the directory. So now you can generate the drill file. So for that, click on this generate drill files. Click on generate. So now you also have the .drl file, which is the drill file. You can close this. After that, you have to come to the directory where these files are getting downloaded, where these files are generated. So in order to send it to the PCB manufacturer, you have to send it in this zip format. So you can do it easily by selecting all of them and just moving it to the zip file. So you can give some name to this project and just create the zip file, and you can easily send it to the PCB manufacturer for printing. So I hope you have enjoyed this video. So thank you.